going. I hope you guys are comfortable. Don't eat that 5-pound muffin all at once, or else you definitely won't be comfortable. You will feel like you have 5 pounds in your stomach, which I'm sure does not feel pleasant. All right, everybody. So just a couple announcements before we get started. Yeah. Tap the brakes on that muffin, okay? You definitely want to make sure that your midterm exam is done. That was due right now, right? It's so yeah, 4.9 repeating. If you guys want, you guys are making my day. If you guys just make sure that that was turned in. I will be grading those. They aren't auto graded, so I'll be grading those today and tomorrow. I have my other geometry class is turning theirs in tomorrow. So those grades will be up by Wednesday at the latest. It really just depends on how long it takes me to grade and things like that. So really important, though, if you did not turn in your midterm, you're going to have to email me at this point because I'm going to be closing the midterm, so you're not going to be able to access it. So if you have not done your midterm and you want to do your midterm, you're going to have to email me. We're going to have to figure out something because you don't have unlimited time to do your test. Okay? So just make sure if there's any issue where you didn't turn it in that you can email me. And then always, as always, check your grades. They're going to be up by latest Wednesday. Okay? All right, guys. So we're into the second half of the trimester. Isn't that crazy? We're in February. We're halfway done with this trimester, which means we're halfway done with the school year. Whoop, whoop. Right? So that's kind of crazy to think about as well. This is the midway point. So just remember that the final now is only going to be off the stuff we haven't tested on. So that means starting today up into the final, that's the content that's going to be on the final. The final isn't cumulative. So yeah, this starts your new stuff. So everything from today onward is going to be on your final. So I'm looking at future you who's coming back to watch videos to study for the final. This is the start. Okay, you want to start here, and that's what's going to be on the final. So we're going to do a little bit of chapter 3, a little bit of chapter 4, and a little bit of chapter 5 is going to be on the final. All right, so let's get started. Let's get into this. As always, if you guys have questions, you can turn on your mic and ask questions. You can use the chat to ask questions, and we'll go from there. All right, so wow. What did we accomplish in the first half of this trimester? Well, we got a lot of vocabulary. We got a lot of basics, right? We got angle rules, right? We have linear pair, vertical angles. We have complementary, supplementary. We did proofs where we took geometry things and then took them to algebra and solved them. So we're going to keep building on that. We're going to be adding more. So remember, math is like a game and proofs are like a game, and we have all these rules. Remember how I made that list of rules that we can use, that the list of things for our reasons? So what we're going to be doing for basically the rest of this first trimester is we're going to be adding rules. So it's super important. If you don't know the rules that we have now, right, then it's going to be problematic when we're adding more rules. So it's really important that you guys are keeping track and you're paying attention, and if you're confused or you need help, that you ask, okay? Because we're just going to be keeping and adding more rules. And today we're going to be setting up for more rules, okay? So the first thing we're going to talk about is parallel lines. Okay, and parallel lines are going to be a huge dynamic in our proofs going forward, okay? So parallel lines, there's a lot of different definitions of parallel lines. So I'm just going to make a list of bullets that make up parallel lines. So parallel lines, you can think of it as two lines, I should say, or more. Two or more lines that never meet in the same plane. Oops, I'm off there a little bit. So two, and then I put or more. We're not going to be doing that a lot, especially in COVID times. So two lines that never meet in the same plane. Now that's not a complete definition, So another note that I would want to add here, because yeah, it's important that they never meet, but what's really important is that the distance between the lines, so the distance between the lines always is the same. So the distance between the lines is always the same. So the great indicator of parallel lines, the great example I meant to say of parallel lines is railroad tracks, right? Railroad tracks are parallel. The lines have the same distance between them, hopefully, right, the whole way. And that's because a train has rigid wheels, right? So they have to be the same distance. They have to be parallel, okay? The symbol for parallel is we just do basically two straight lines like this. This means parallel lines. Okay, so that's one way we say parallel lines. We just draw two vertical lines and two vertical segments, and we call that parallel lines. Okay, so that's the symbol. This is the symbol for parallel lines. It's just two straight lines up and down. It's like an equal sign on its side. Okay. Another way that we show parallel lines is, now first, I always get students with this. If I go like this, in chat, can you guys tell me if these lines are parallel or not? And there is a correct answer. So are these lines parallel or not? Say yes or no. This is a test. I want to see what you guys say. Are these lines parallel or not? So do you guys see how, like, well, I see that I'm getting yeses and I'm getting nos. But I liked one answer in particular. And someone said, yes, I think. Oh, that's perfect. And that is the problem. Don't they look like they're parallel? But you don't know they're parallel. And remember, math, there's a right answer and a wrong answer. So if you're not 100% sure, they're not parallel. And so what I mean by that is you can't just look at something and say they're parallel. It has to tell you. And that, I hope that's a big lesson that you take from today. You can't say something is parallel, and you just can't look at something and be like, those are parallel. You guys don't have a superpower where you can just look at something and say they're parallel. And if you do have that superpower, I know every construction company in the world wants you to work for them, because you could just look at something and be like, yep, that's parallel. Okay? So, there's a couple of different ways we can do this. If I call this line N and I call this line P, we could say N is parallel to P. So this reads as line N is parallel to line P. Okay, so N right here, N parallel P. So this reads as line, and I should put quotation because it's how it reads. Line N is parallel to line P. But look how English, right? Like, we don't want to write this all the time. So we can say N is parallel to P. So that's line N is parallel to line P. Okay? Another way, so this is way one. Should go like this. So that's one way to have parallel lines, right? It says N is parallel to B. The other way is that they show it graphically. And to show it graphically, all you need to do is you add another pair of arrows pointing the same direction. This right here means that they are parallel. And the beauty of this now is even if you don't draw perfectly parallel lines, just by adding in that extra set of arrows, they are now parallel. Okay? Your book, so in your homework, your book likes using little red arrows. I feel like I should have used little red arrows. Okay? So if you don't see those little red arrows, and this is what, here, I can show you in the book what that looks like. I gotta zoom in a little bit though. Do you guys see those little red arrows? Yeah. Here, I'm gonna autofocus here. Boom. All right. You see these little red arrows? Those little red arrows, that tells me that in this case, line N and line M are parallel. Okay? So that's a quick and easy way of saying, hey, these lines are parallel without having to like make sure they're parallel. Okay? And this year, because we're in COVID, we're actually not going to talk about how to make lines parallel, though it is easy to do. And if you've ever worked construction or built something, making parallel lines is really important. And there's a couple of different ways you can do that, whether you have a right angle tool, like a right builder's tool, or you use triangles. And a lot of construction people use triangles because if you cut pieces correctly, you're going to end up with parallel lines. Anyways, so we have this, parallel lines. So parallel lines, it means two lines that never meet. The distance between them is the same, right? So what we're saying here is if this is D, then this is D, right? So the distance never changes. There's two ways to name them, right? You can say in the picture, just add a couple of extra arrows. That means parallel. Or you can say N parallel P, which stands for line N is parallel to line P. And what this does, right, it just takes out all the English. So if you go anywhere in the world, people would know what this means. Pretty cool. Pretty neat. All right, so that is parallel lines. Okay, and then I'm going to do all of these at once, and then we're going to do a little practice together. Now, the next one is probably one you've never heard of. And that's skew lines. And you got to be careful. Some of you I know know a little bit about statistics. It does not mean skew as in skew in statistics. Actually, interesting fact, did you know that statistics actually isn't considered math at most universities, at big universities? It's its own subject. Okay, so skew lines. So a skew line is a lot like parallel lines, but notice the subtle difference here. So the subtle difference is going to be it is two lines that never meet. Now, if I stop there, you'd be like, wait, you're just writing exactly what parallel lines are. This is where it gets different. So it's two lines that never meet in different planes. Okay, and that's what's different. That's what's different between the two, is the word different. Okay, two lines that never meet in different planes. Okay, now I'm going to have to draw a picture to do this. And there's no fancy symbol for skew. Skew isn't used as much as parallel. Parallel is used all the time. So let's do an example of this. Okay, now skew lines happen when we have 3D or higher shapes. Okay, so I'm going to teach you guys today how to quickly draw a 3D box. Okay, to draw a 3D box, start with a two-dimensional rectangle. Okay, now we're going to use one of the words we're going to do parallel. So we're going to start with these 3 points, so everything but the bottom left. And what we're going to do is we're going to start with one and draw a line back. Now, whatever line you drew back, you want to draw that exact same line parallel from up here. So you want it to be congruent. Same length, like this, and then you want to draw it here. So basically, we're drawing this line back, here, here, and here. They should be parallel and congruent. Okay. Then, notice this line up and down that's connecting them. We're going to draw that line parallel, up and down, connecting it. And then this line right here, we're going to draw it parallel, connecting it. That was a little off. Now, to add a really cool three-dimensional effect, you notice how backwards, right? We did all those. Make this one dotted. And then make this one dotted. And then make this one dotted. So now you have a really cool 3D effect box. Okay, and it was created using parallel lines. Okay, so again, all of the lines I added were parallel. Now, if you're like me and you're trying to copy this down, I bet your first one isn't going to look so great. My first ones didn't look great either. But you have to remember that as a geometry teacher, I've been making these for 12 years. So even then, mine doesn't look super great. But the idea is now let's go ahead and I'm going to label some stuff. Okay. So I'm going to highlight this bottom piece right here. Let's call it AB. Okay. Then I'm going to highlight another piece. I'm going to highlight this piece right here. I'm running out of ink. I'm going to call this CD. Now, when we take a look at these two, are they ever going to meet? Right? So you have this one going up and down, and it's in the back, and you have this one going left to right, and it's at front. Are they ever going to meet? No, they're never going to meet. But that doesn't mean they're parallel, because they're in different planes. AB is on the front and the bottom, and CD is on the right and the back. So they're on different surfaces of my box. So they're not going to meet each other ever. They're not going to intersect, but they're also not on the same plane. Or in this case, you can think of the plane as being a surface. Okay, so we would say, how would I say this? I would say segment CD is skew with segment AB. I don't know if you would say with. I don't use skew a lot, but I don't think I would say with. Here, I'm going to change this. I'm going to say segment CD and segment AB are skew. Okay? Which might be different than if you've ever built something and it's askew, or if you're using statistics and you say that the data is skewed. So skew just means two pieces that are in different planes that don't meet. Okay? Whereas parallel, we're really only talking about, you know, in the same plane, right? They're not one above each other. Okay? You might think of this like, right? So I might complete this and say, hey, I might have railroads here, and then this is a post coming out of the ground. Okay? Like maybe this is a stop sign. A blue stop sign. I don't know. Right? So another example, right? So here's my railway. My railway is parallel to each other, but you see this post and this railway will never meet, but that doesn't mean they're parallel. That means they're skew. All right, whatever. I thought that would help you. Hopefully that helps. I tried to give two different examples. So skew just means two lines or shapes that never meet, but they're in different planes, so they're not parallel. Okay, how are we doing for time? All right. We got a lot to do today. Maybe I'm spending too much time on that. Okay, next up is perpendicular. So this is the end for our line relationships. So perpendicular, I should say perpendicular lines because we're talking about lines. So I made that into an L. Okay, perpendicular lines. It's just two lines that meet at 90 degrees. So two lines that meet at 90 degrees. An example of this. So again, I want to see if you guys learned anything. So I didn't do lines, I did rays. Are these two rays perpendicular? Let's see if you guys picked up what I was trying to say earlier. So in the chat, just yes or no, are these two rays perpendicular? And yeah, I appreciate the direct messages. Thank you, I appreciate that. Okay, so are these perpendicular? Okay, so I'm getting all over the map. I'm having some people say yes, I'm having some people say no. Guys, so again, the key from this is that you guys are not superheroes. I am not a superhero. Your super strength is not the ability to look at something and say, oh, I just measured that angle. Okay? Now, you might be able to say, that looks like it's 90 degrees, but we can't say it is 90 degrees. Okay? So, the only way we can say it's 90 degrees is if there is a box. Okay? Now, there is a symbol for perpendicular. So we would say ray AB, and perpendicular is an upside down capital T to segment AC. So this means perpendicular. Okay? An upside down capital T. That's really all we need to know there. So again, you can't look at a picture, because if you do that, you're going to try to do proofs and you're going to be like, well, yeah, it is 90. Okay, you can't just look at something. We want to be able to prove it's 90 or know it's 90. Now, it might be close. You might be like, well, I have people in my family always tell me it's good enough for government work. It looks like it's 90. We're good to go. Well, that's not what we're here for, okay? We're going to be exact. All right, excellent. So what I want to do now is we're going to do a little example of this. And to do an example, you guys don't need to, so you don't copy this into your notebook. Don't do that. It's a waste of time. Here's a box better than I can draw. Okay? And I'm going to hit freeze. Call me Mr. Freeze. All right, so that's frozen. All right. So what I'm going to do is I'm just going to ask some questions, and I just want you to think about it. Okay? So first off being, what segment would be parallel to CD? So let's see if I can't draw a little something in here. Okay, so again, I want to know, oops, how do I erase? Looks like I was doing a whole bunch of algebra. So I want to know if I have CD here, I want to know what's parallel to CD. And you guys can type that into chat if you want. Just what is parallel to CD? And I'm going to warn you, there's more than one answer. Oh, you guys are doing really well. You guys are doing really well. So the answers were, what is parallel to DC? Now remember, with parallel, they have to be in the same plane. So so some people are saying AB. Okay, so these two are parallel, right? And we know they're parallel because you guys see how they're at 90 degrees, so this distance is going to be the same. That's kind of the kicker. I kind of remember how I said don't assume. So these are 90. We're going to learn how to prove parallel lines. Sorry. Yeah, I agree. We're going to learn how to prove parallel lines. So we got those two. And then we got EF, right? So AB and CD, those are on the top, EF and CD. Now, this is where people are going to maybe get a little upset. A lot of people, only one person got the third one. There's a third one. Are you guys ready for this? If you were to cut this shape diagonally, then you would also have HG. Do you guys see how this in the blue is a plane? Isn't that crazy? Okay, so there's actually 3 answers, and I'm just going to go ahead and steal a student's answer and share it with everyone, but not say who it's from. Right? Those are your answers in chat. So all the red ones would be parallel. So you have the top one that shares the top, you have the left side one that shares the bottom, and then you have that diagonal one. That one's a little bit harder to do. Okay? Here, I'm going to erase all of this, and then... Okay. So for our next one, I'm going to set this up again. So here's DC. This is our start. Okay, can you guys come up with 2 different lines that would be skew? So here's CD in green. I want you guys to name 2 segments that would be skew. That is, they don't intersect, but they're not parallel because they're in a different plane. So in chat, try typing in what would be a segment that would be skew to CD. Okay, so someone sent me a H. That would be one. Someone said BG. Oops. Like that. So that would be another one. Someone said HF. So I'm not going to draw in HF, though that could be one. For this one, we're only going to use existing labeled sides. So even when I used HD last time, that side existed. So I'm not going to use HF. I can use a FG though. CF. I can't use C because C, that would mean it intersects, right? So CD is already used. So I can't use here. I'll draw it on. I can't use CF because doesn't that intersect right there? So I can't use that one. I can't use CF. EH. Yeah, EH is the last one. Boom, right there. So we have EH on the bottom, FG on the bottom. We have AH and BG. Those would all be skew. It can't be DH as you can't. So anything that has C and D in it. So if I go DE like that, see how it intersects right here. And the definition is that it can't intersect. Just like we can't have CF, it intersects right there. So because those intersect, we can't have that. Okay? And this is why we're doing this, because if we were doing this in person, we would be able to talk a lot more and we'd be able to, but I'm just trying to show you guys different examples of skew. All right? And then our last one here, let me erase here. Our last one, sorry, I got to get bigger. Our last one, so if I go here in green, so if I'm looking, I didn't have to erase CD. If I look at CD, can you guys name name a line that is perpendicular to CD? So what's a line perpendicular to CD? What do we got perpendicular? So I want a line perpendicular. And look at those red angles there. It gives us a hint, right? Okay, so yeah, lots of answers. Oh my gosh, yeah, they're pouring in. Okay, so let's see here. We have ED, that's perpendicular. We have DA, that's perpendicular. We have ED, okay, CB. Sorry, you guys are coming in hot and heavy. I'm trying to get all of them. And then CF, that's the other one. Okay, so there's 4 answers. There's CB, DA, EF, and CF. So remember, with perpendicular, it does intersect, right? It meets at 90 degrees. So those do intersect. So they intersect at D and they intersect at C. Those are the 2 places that it intersects at. So really good stuff, guys. So that's just examples of perpendicular, parallel, and skew. All right. Let's zoom out here. Boop, 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 boop. There's my arm. All right. So that's what we have for line pairs. But we're getting to the next things that are even more important, and that is angle pairs. Okay, now angle pairs are super important. And when we're talking about angle pairs, I have a couple of new words that we need to talk about. So the first new word is called a transversal. Now, what's cool about this is that this actually has 2 root words in it. Transversal. Transversal. So you guys know you guys have heard both of these words. So for example, you've probably heard the word trans used in other words, right? So you might get on a plane and it might be a trans-American. You might get on a plane, it might be trans-Pacific or transatlantic. Or you might get on a train, or you might get in a car ride and you go on a trans-Washington trip or a trans-Skagit trip. Or you might know someone who's transgender. Okay? So trans means to cross. And then versal. Versal, you might know the word versal from universal or universe, right? So right now there is a universal mask mandate if you're going to see each other in person. So universal means everything. Una meaning one everything. So there's one rule for everything, universal. Okay, universe means there's one everything. Okay, that's what those root words mean. Yeah, cool, right? All right, okay, cool. So that's what it means. A transversal is something that crosses everything. So in our use of it, we're going to use a transversal line. Okay. Now, when you have a transversal line, it creates angles. And that's what we're going to focus on for the rest of the short time that we have together. Okay, we have about 8 minutes. So we're going to look at different angle relationships. Okay? And we're just going to, today, all we're going to do is identify them and name them. We're not going to do any algebra. We're just going to look for them and be able to name them. Okay? So let's say I have two lines. I'm going to call this line A, and I'm going to call this line B. Okay? And my question, are these two lines parallel? I'm double checking in on you guys. Yes or no, are these lines parallel? Now, are they not parallel because they don't look parallel? Or are they not parallel because it doesn't say they're parallel, right? So it doesn't say they're parallel, not just because they don't look. Again, we don't have superpowers. Okay? Oh, I love that answer. We don't have enough information, unknown. Good stuff, guys. I like that. Some people go an extra mile. What I'm going to do with these two lines is I'm going to draw in a third line. And notice how this line crosses everything. This line is a transversal. Okay. Now, I like to think of a transversal as a trip. This transversal takes you across everything. So if these were two streets and I'm going to my friend's house, I'm transversing those two streets. Okay. Mountaineers say they transverse a gap in a glacier, a crevasse. They transverse a crevasse. Ooh, that sounds so crazy and so cool. Transversal, I used to do that stuff. It was really fun. Transversals go across. Okay. Now, when I drew that, though, take a look at all of these angles. In fact, as soon as I do a transversal over these two lines, I get a lot of angles. So I'm going to label these 1, 2, 3, 4, 5, 6, 7, 8. I got 8 angles. Now, there's going to be a ton of angle rules here. Okay, so we already got a transversal. That's the line crossing. As soon as we add in that transversal, we get all sorts of angle stuff. Okay, so we're going to go through and we're going to name them. Okay, and that's all we're doing today is we're naming them. So the first one that we're going to talk about is corresponding. So corresponding means angles in the relative same location. Okay, that's going to work for us right now. So angles in the same location. So I like to think of this as, you can just think as location. So notice angle 1 up here. Angle 1 up here is in the upper left. Do you guys see that? This is the upper left. So is there another angle that's in the upper left? Yeah. Angle 6 down here is in the upper left. Oops. Angle 1 and angle 6. So are both in the upper left. I'm just putting that so you remember. So they're both in the upper left. And someone had a really a good comment about the vertex. Do you guys notice how they're kind of grouped, right? Here's a group and here's a group. You can think of this as two cities. So in this city, 1 is in the upper left. In this city, 6 is in the upper left. And we can do this with all examples, right? So another example would be angle 2 and okay, what does angle 2 go with? Well, angle 2 is in the upper right. So what does angle 2 go with? You guys can type in chat. Come on. Yeah, angle 5. So angle 2 is in the upper right, angle 5. So these are corresponding angles. Okay? And we could keep going. Angle 4, right? Angle 4 is in the bottom left. So angle 4 would go with 8. And then we got one more. Angle 3. And so angle 3 is in the bottom right. That's going to go with angle 7. Okay? So corresponding angles in the same location. You can think of these as cities. Okay? And they're going to be in the same location in the cities. Okay? So that's be like, I live on the west side of Mount Vernon, and Mr. Kreft lives on the west side of Mount Vernon. They live in corresponding parts of their cities. Okay? They live in the same location in their cities. Okay? Corresponding. Okay? Next up. Let's talk about alternate interior angles. Okay, I have just a few more. So alternate interior angles. So again, we're looking at pairs of angles. Okay, so let's break this down. Alternate, if you ever work on cars, alternate means to switch. Okay, and interior means inside. So they're going to switch inside. Now, the switch, alternate means to switch sides of the transversal. So I'm going to say that down here. Switch sides of transversal. Okay, so alternate means to switch sides of a transversal. So we're looking for angles that are inside and they switch sides of the transversal. So to do this, what I mean by inside, do you see how A and B are like the top and bottom of a sandwich? And this is like a toothpick going through. Or it's like a really big burrito and I have to put a toothpick in it to keep it all together. Okay? So I have the top and the bottom. So that means the inside is here. So this is the inside. This is the inside. Okay, right? This would be the outside. Okay, now, if I'm looking for a pair of angles, I know it's not going to be 4 and 3 because doesn't that already have a name? 4 and 3 are a linear pair. And it's not going to be 6 and 5 because that's also a linear pair. This is a new angle relationship. So in this case, it's going to be angles. So again, it's not going to be 6 and 5. I hope that makes sense. It's not 6 and 5, and it's not 4 and 3 because those are linear pairs. I really appreciate the person who shared with me. What about 4 and 6? They're both on the inside, and they're not alternate. They're not linear pair. But did we alternate? Did we switch sides of the transversal? So if I'm at 4, I'm going to go down, but I have to switch sides of the transversal. So angle 4 and angle 5. Okay, and angle 6 and angle 3. If I were to draw a picture of this, it would be these two and these two. So I just drew a little mini version of that, right? Without. So they're alternate interior angles. Hey guys, I'm going to go over just a little bit. I have one more that I want to do. And that is alternate exterior angles. I lied. I have two more that I want to do really quick. So alternate exterior, so it switches sides of the transversal. It's on the outside. So if I were to do an example of that, it would look like this. So it's the same idea, but on the outside. So it's the exact same idea, but on the outside of the two. Okay. And I'm so sorry, guys. I don't want to take your time. I have one last one. So just get these down and then we'll be good. And that's consecutive interior. So consecutive means one after another. But what you guys really care about is just give me the picture, because we're not doing equations now. We're just identifying. Consecutive interior would be on the same side. Like this. So the pictures are just going to have to suffice for right now. So in your homework, what it might say is it might give you a picture like this, and it might say, what angles are alternate exterior angles? And you'll be like, okay, angle 1 and angle 7 are alternate. Oh, are we out at 11? Oh my gosh. Okay. Woo! Guys, we're out at 11. I have more time. You guys saved me. Thank you so much. I'm having like a panic attack over here. All right. So, I want to practice doing this. So, check this out. Again, you don't have to copy this down. Let's practice identifying these things. So, first thing we're going to practice. Okay, let's do this. Can you guys name two pairs of alternate interior angles? And you can just do the number, comma, the other number. So can you guys name a pair of, so this is how I would do, how I would write my answer. Here, just a second. I would write my answer like this. A, B, and then that, and then. So look in chat how I wrote my answer. You would replace A, B, C, and D with numbers. So can you guys tell me what the two pairs of alternate interior are? Oops. Got to erase that. Ooh, yeah, you guys are doing, doesn't it help to have that little guide? 14 and 23. I think, so if it was 1 and 4, so if it was, here, let's go like this. If it was 1 and 4, like that, those two, that would be vertical angles. Okay. And 2 and 3, those would be vertical angles, right? So vertical angles and linear pairs, those are still going. So for alternate interior, we're going to have 2 and 7. And we're going to have 4 and 5. Okay? These are alternate interior. Okay? Alternate interior. Oops. Go really big. Wish there was a better way to erase. Okay. Our next one, and maybe I'll type it into chat. Yeah, that's what I can do. Can you, so let's do name two pair of corresponding angles. And then I'm going to type that into chat. Okay, there we go. So name two pair of corresponding angles. So angle what and angle what would be corresponding angles. So again, you're just naming two pair of corresponding angles. Okay, be careful. I'm going to give people a hint. Remember your corresponding cities. So I circled in blue, that's one city, and then in green, that's another city. So you're comparing groups. So remember, we want the same location in different cities. So same location, different cities. And hopefully the color helps out. Ooh, yeah, I'm getting some really good ones. I'm getting some good ones. Ooh, yes, yes, yes. Ooh, yeah. Very nice. Guys, you guys seem to be getting this, right? So again, we're comparing the blue city to the green city. So let's take a look. I'm going to go ahead and highlight answers. So 1 here is in the upper left. That would go with 5. 2 is in the upper right. That would go with 6. 3 is in the bottom left. That would go with 7. And 4 would go with 8. So again, identify your 2 cities, and then it's the same location for each. I hope this is helping out. I hope you guys are doing okay. All right, so these are corresponding angles. So corresponding means you look at the cities and you say, okay, location-wise, what's the same, how can I compare these locations in different cities? Corresponding, you can think of same location. All right, let's get real big and erase that. No, corresponding angles, we're going to talk about that next class, but they do not add up to 180. So we're not doing any math with these now. We're just identifying them. We're going to get properties, and I'll prove those to you. So like are alternate and interior the same? Do they add up to something? Is there a relationship? We'll do that next class. Okay? But for right now, we're just naming them. And no, they don't add up to 180. Okay, can you guys find 2 pair of alternate exterior angles? So alternate exterior. And I'll type this into chat so you guys can see. So alternate, oops. So I want you guys, oops, no. Don't do alternate interior. I said alternate, alternate exterior. I want alternate exterior. Ooh, you guys are doing really great. Some of you guys are like right on top of this. Some of us are going to struggle a little bit. And so I want to be helping the people who are struggling a little bit. Just try your best, especially if it's a direct message, guys. Only I see it. Only I see it. And the people who are sharing so far, everyone who has shared has been correct. So you guys should be feeling really good about yourselves. Ooh, yeah, we got to be careful with that one. So again, I'm just going to identify here using blue. This is, everything in blue is the inside. Ooh, that's a D. I'm so sorry. So that's the inside. So we want everything that's on the outside. Okay, so for example, that means we can't use angle 2, we can't use angle 5, we can't use angle 7, and we can't use angle 4. So my answers then would be 3 and 6, and what else do we have? I need a different color. And 1 and 8. Yeah. Yeah, you guys are good. Oh, you got it. Excellent. Okay, so those would be, these are alternate exterior. They alternate what side. Do you see how they switch sides? They switch sides of the transversal, and they're on the outside. Okay, so ladies and gentlemen, to close things out today, there's a couple of things I wanted to talk to you guys. So you do have a homework assignment tonight. It is due Thursday. Please remember, there's a couple of things. If you did not do your midterm, it was due at the beginning of class today. You need to email me to do that midterm if you did not do it. Okay, so if you did not do your midterm and turn it in, you're going to need to email me to be able to do that. Next, make sure, guys, you remember 80% of your grade is assignments. So if you have missing assignments, get those done. There is no late work penalty. You can turn in late assignments anytime you want until the last week before the end of the trimester. Okay? Also, if you guys turned in an assignment and you got a grade that you didn't like, you can email me with what assignment it was and what period you're in, and I can unsubmit that assignment and you can redo any assignment. So if you guys are looking to improve your grade, there is lots of ways to improve your grade, and you want to do it now instead of later so that you can get your grade up before the end of the trimester. Okay, guys, that is the end of class. If you have any questions, you can stick around. I will see you guys